So, welcome everyone. It's great to see so many familiar and new faces in here. My name is Csaba Szugyiczki, and together with Péter Marogna, we are going to talk about Android unit testing. And our agenda for tonight is the following. First, I would like to discuss why we think that it's still important to talk about unit tests on Android, or in general, actually, because our first topic will be general Kotlin-related use cases that you might run into. And maybe it's not that easy to find some answers to those. And most importantly, the Android-specific use cases will be covered by Péter, and then we will discuss the conclusions that we came to. But before we dive deeper, as István already mentioned, we are hiring. We have many positions, but most importantly, we have Android developer and senior mobile engineer positions. If you want to find out what's the difference between these two roles, then follow the QR code. But let's dive in. So, if you start to look for resources about testing online, then what you will see that there are really great articles and meetup talks about testing in general, like really high-level stuff. It will be covering unit tests and integration tests and UI tests and smoke tests and whatnot. And you will know all about them, and they will usually just draw a testing pyramid for you, which will tell you that, okay, these tests should be the most in your code base, and you should write less UI tests, for example, because it's hard to maintain them. And you will find everything about mocks and stubs and spies and doubles and all these different techniques that you might use during testing. And we don't want to talk about these kind of stuff tonight. It will be really practical stuff. We ran into some issue, we looked online, we found some good solutions and not that good solutions, and we will discuss the differences between them. And the definitions for tonight, whenever we say unit, usually we will think about a class or a top-level function or an extension method. So if we say unit, we mean by that. And during our tests, you will see mocks and stubs. Without going into further details, this will mean that we will have some kind of instance creation, and these will just return the same value that's predefined already. So, and keep in mind that these samples are really oversimplified. We have something like this in our codes, but just to fit on those slides, these are really simple ones. So the first one, dispatchers. Of course, we are talking about the coroutine dispatchers. And this comes to testing async code, which can be really tricky because you have to be sure that when you are making your asserts and you are validating that your function was running correctly, you have to be sure that it's already finished running. And that could be a challenge. When you look online, one of your first results will be this super page from the Android developer site, which will tell you all about the best practices when it comes to coroutines. And one of the first things that you will see there is that you should inject your dispatchers. What does this mean? On the top, you see the bad example, where you just create your repository and you have your load news function, and it just tells to the coroutines that it should use the default dispatcher to run this code. And this site will tell you that you should inject your dispatchers, so you are not using dispatchers by themselves, but you will get it as a parameter. Why? Because in your tests, you want to run your coroutines on a test dispatcher. That's why. But what if you are working on a legacy code? It's a huge app, and no one really thought about this when it was written. It could be overwhelming to think about just refactoring the whole code just to start writing some unit tests. So we are engineers. When we are facing problems like this, we like to get creative. So what if instead of refactoring, we would use reflection? So reflection can be used to change all kinds of things during runtime, right? So what could go wrong? There's this set main method for the main dispatcher. You can use that, so there's no problem. But for IO and default dispatcher, there's no such method. So let's try reflection. So you look online, and after a casual conversation with ChatGPT, you will end up with something like this. And you run your code, and you will get something like this. That's because on JDK 8, it used to be working, but since Android Gradle plugin 7, we are using JDK 11, and now it's not working anymore, thank God. But then you will look online, and you will find something like this on the bottom of some shady GitHub issue. And then you run your code, and you will see something like this. That's because it used to be working on JDK 12, but since Android Gradle plugin 8.0, we are using JDK 17. Thank God. But then you think, okay, there are these mocking libraries. They are really cool. And they can just mock some static stuff for us. So why not use mocking to just change the dispatchers? So let's see this example. We have a really short little main view model. It has a dependency on the main repository. And what it does is just starts a new coroutine on the view model scope. It will use the default dispatcher by itself. So we want to change the default dispatcher in this case. And it will just call a method on the repo. And if we write a unit test like this, you will see that we just create a mock repository. We create our view model. And we tell the mocking library that from now on, when we say dispatchers.default, we want to use the test dispatcher that we just created. And if you run this code, then it will work. Magic. But if you tell the mocking library that you want to mock the repository's suspend function after you told it to use the default dispatcher as the test dispatcher, then it will crash. Oh, really interesting. It says something about fold and stuff like that. So if you look online, you will find an answer like this, that you should start mocking fold and plus and stuff like that. Really shady stuff, but it will actually work. For how long, I don't know. I have no idea. But please don't do this. What you should do is just be a good Android citizen. Never do this stuff that you just saw earlier. We ended up refactoring the whole app. And to be able to use dispatchers in a convenient way, we created a helper dispatcher provider, which I will just show in a minute. But first, keep in mind that we are changing the main dispatcher with the setMain method. That's easy. So we have a dispatcher provider like this. You can use whatever dispatcher you would use directly. But instead of just using the main IO and default, when we are running the app in production, it will just use dispatchers main, dispatchers IO, and dispatchers default. But when we are running tests, all of them will point to main. And actually, main will be the test dispatcher because it was changed for all our tests with the test rule. And in this case, we saw this code snippet earlier, but we don't have to tell during DI time that we want to use this dispatcher for all of the suspend functions within this repository. You can still decide within the repository which dispatcher you want to use, but you will not use them directly. If you want to avoid this mistake, then there's this really good detect rule. If you turn it on, then it will just throw an error whenever you try to use a dispatcher without being a dependency. So if it's a parameter and you just give it a default value, it will be okay. It will pass, but otherwise it will just show you an error. Then, next up, suspend functions. How do you check if a suspend function throws an error? Let's imagine that you have some suspend fun that will take a parameter. Based on that parameter, once it will just throw an error. Otherwise, it will just do some business logic for you. So you want to make sure that it will indeed throw an exception. The default JUnit assertions will not really work here. And it's surprisingly hard to find the right answer online. Maybe I'm just not good with Google yet or with ChatGPT, but it's really hard to find the correct answer. Because what you would use, if it wouldn't be a suspend fun, you could use the JUnit assert fun function. It takes a runnable, and whatever you run inside, it will check if it's thrown an error, and if not, then this assertion will fail because you were waiting for, in this example, an illegal argument exception. But this will not even compile because within this assert throws block, you want to run something that's not async. So what if we launch the coroutine? So it will be sync, but within the launch we can start a coroutine. Well, you can do this, it will compile, but you will return from the runnable even before this coroutine had a chance to start running the suspend fun. Okay, if this is the problem, just use an unconfined test dispatcher. So your coroutine will be running immediately. You can do this, it will compile. But in this case, your test will catch the exception and not the assert throws function. What you can do still with the regular JUnit test suite is that you can tell to the test annotation that you expect an illegal argument exception. Actually, this will compile, this will work, but the problem with this is if you want to check that after the exception, you want to verify some things, you have no chance because you will never reach that point. So the real answer to this question is that you should include into your test the Kotlin test package, and then you will have the assert fails with inline function. And since it's an inline function, you can use the coroutine scope that's created with the run test. You can just call your suspend function. You can assert that it failed, and after that, you can do all kinds of verification. Next up, clocks and time and dates in general. We know that this is really hard to nail, even in our production app. So testing it should be harder. And it's really hard to test timing because you want your test to be consistent and repeatable, and you don't want to depend on which time was my test running, what was the time zone on the machine that my test was running. So there are all kinds of stuff that you have to think ahead. So for this, let's imagine that we have a user service. It does nothing fancy. It just creates a user for us, but it will create the timestamp when the user was created. Let's try to write a test for this. When we create the user service and create a user, it's okay. And then we want to assert that the creation date is something. Let's say it's instant.now because we were using that within the creation method. And unfortunately, some milliseconds has passed since that time, of course. So what we can do, of course, we could use a mocking library or reflection, but we already saw that that's not really the answer to these questions. So what you can do is, actually the Java clock has this fixed factory method, and you can just pass an instant and the time zone for it. And from that point, it will always tell you that this is the time, no matter how many milliseconds has passed since that, it will always just tell this is the time. So if you want to be sure that all of your code that is using some kind of what's the time now methods, you should pass a clock to them if you want to test them, because this way, what you can do, from now on, we will not call instant.now, we will call instant.now with a clock. And now this now method will use the clock to tell what the time is right now. And you can change your test to create a fixed clock. We will just pass an instant to that, and let's say it's UTC. And now we create a service with this fixed clock, and then we can assert that the creation time is this fixed time that we supported for this clock. If you want to, then you can create your own clock, so you can alter the time between runs. You can do whatever you like. You just have to keep in mind that you should be able to pass the clock. But if you started to use Kotlin multi-platform, then chances are you are using the Kotlin X datetime API, but it doesn't have a fixed clock implementation yet or ever. But fortunately, the clock interface for the datetime API is really simple. It doesn't have anything else but a now function, which should return an instant. So let's write it ourselves. Here's our fixed clock implementation for the Kotlinux datetime API. We say that we are a clock, we have a now function, and we take in a fixed instant as a parameter, and whenever anybody asks what the time is, we will say that it's this instant. So we can create a factory method for this, so it will look like the Java clock API. And then, once again, in our tests, we can say that we want to create a clock that is fixed, and it's for this fixed instant. If you want to avoid these mistakes, it's actually not that easy, because what I could find is you could use the forbidden method call detect rule, but this time you will have to tell the system tell to detect that you want to prevent the now calls. But for every type, you have to say, okay, this is forbidden, this is forbidden, this is forbidden. It's not that easy. If anybody knows about any better way to just use detect or any other analyzer, then I'm all ears. And now we will dive deeper into the Android specific use cases. So I'm handing over to Péter.
Oh, hey everyone. There's really a bunch of people. That's really good. I won't introduce myself once again. I'm Peter, and I will show you some examples we saw during our application developments, which are really Android specific. So first of all, we will see location, which is an Android class. I think most of you have already heard about it. At first glance, you will think that it is some kind of data class returning different properties. Well, basically it is. It just has some Android-specific features that makes it a bit more difficult to test. I will be talking about location, but most of the different sensor-related data that are returned from the Android system behave similarly. So I will show you pretty much a lot of code, but bear with me. They are oversimplified, as you said. So first, let's suppose we have this location service class. It is really simple. It has one method returning the last known position of our user. It has a mapping, and let's see what is happening within that mapping. We created our own domain class, which is this coordinate. It has a pretty simple latitude and longitude. And as you can see, there is an extension method that does the mapping for us. There's a little catch. The mapping only happens when the accuracy is good enough. So if this position was within 10 meters, if not, we will return null. Let's see a test for this case. Here, we are creating a simple location instance. With the apply method, we are setting the accuracy to be over 10 meters, calling the mapping method, and checking whether we get null or not. Unfortunately, for this, we will get this error saying that the set accuracy method for the location is not mocked. This is because, as I mentioned, the location class is strictly attached to the Android environment, and we won't get any insight for it. I'm sure you have used many different libraries while working, and when you don't have their source code downloaded, you will see something like this, that basically every function will have this runtime exception throwing, as it says, it's a stub, and basically nothing will be there for what you expected. To fix this, the first thing you can do is use Roboelectric. I'm sure most of you had already encountered Roboelectric. It's a tool that simulates you an Android environment underneath your unit test, so that this way we will be able to create a location object. Again, the test is the exact same that we saw before, and finally this will run. So a bit more about Roboelectric. As I said, it sets the Android environment underneath your test. It can be used to mock like services, activities, and whatever related to the Android environment. But unfortunately, there's a catch. As you have seen, most of our tests were written with JUnit 4 or 5, but there's this issue within the Roboelectric repository saying that it's not working with JUnit 5. And this photo has been taken a few days ago and has been open since 2017, so I don't think it will be fixed soon. So we need a workaround for that. Maybe the first idea of yours wasn't even to create a location object, but just to mock that. Fortunately, it will work. So creating a mock, we are using mock k here, a simple object, overriding the accuracy, returning the same exact value I presented before, and this way our test will work. Yay. As I mentioned, this also works with the other Android-related classes. Let's switch to our second topic. This is the preferences data store. Again, I'm almost sure you have already used it. This is the descendant of shared preferences, and it was one of the first libraries available on Kotlin multi-platform. You use it to do different caching, saving flags, whatever reason you need to save something persistently. And as we will see, mocking is not always the best solution to use the tests. Okay, given we have this tutorial repository, we have an application, we are presenting our user some kind of tutorial, and we don't want to show it once again, so we'll save this tutorial scene flag, so in later usages we won't start this once again. Okay, that's a lot of code. First, we will try to mock everything. Well, data store, preferences data store, as its name says, it consists of two parts. One of them is the preferences, which luckily can be mocked pretty easily. As you can see, it's a few lines of code. But when going to data store, you will see that you have to mock pretty much a lot of other things to be able to use it as a mocked something within your test. And it gets a lot of code. Obviously, you can extract it, reuse it in another tests, but it's still a lot of code, and it's sometimes it's not even working if you are extracted it. The test again, you are calling the method, checking if verify actually whether that flag was set to true, and this test will actually run. Okay, let's see how we can improve this. As we have a look at data store, it has a pretty simple interface. You only have to override this data property and this update data method. As you can see, if you put a simple mutable data flow, mutable state flow underneath it, you can create a really simple fake and use it within your test. But if we proceed, we will see that preferences does not have this simple interface. Actually, you cannot create a fake of it because all types of preferences have an internal constructor, so you won't be able to call them outside of their library. But at least you can create your fake data store, pass that to the repository, and again you can do the checking to verify whether the tutorial scene flag was saved or not. We got somewhat better, but let's see if we can do even better than that. And the case is that we can. We can use a simple in-memory data store, creating it with some kind of temporary directory. This exact example is written in JUnit 5. That temdir annotation is coming from there. But there is also another, in JUnit 4 you have actually this temporary folder rule which does the exact same. So you pass this in-memory data store to your repository, call the method. And this time you obviously won't be able to do the verification as you don't have a mock passed to the repository. You will actually need to check whether this data was saved or not. So as you can see, here we are reading the data and checking whether it is what we were expecting. This will also run. It will be a good test. Yeah. And for our third topic, I would like to talk you a little bit about the build. But what is this build I'm referring to? Actually, this is a composition of build and build config together. So within the build class, it is a static object actually in Java. You will find different system-related informations like the SDK version and so on. And within the build config, you can define your own variables, like for example, different URLs for your flavors, or also you can put in there For example, if you want to use logging within your debug application, but not in your release application. Also for the build config, it's true that they are only visible in the module they are defined in, which will be more important later. Again, that's a lot of code. You don't really need to read the whole thing. It's a simple permission repository in which this necessary permission function method returns a list of permissions. We are checking the Android version, the API level, and we are returning the list of the related location permissions. And of course, we really like the different devices. So if it's a Samsung, they have this illness called, they are able to ignore the battery optimization. So we are also checking for that permission. So it will return a list of these strings permissions. Let's see our first test. So we are again accessing Android-related stuff. For this, we can use Roboelectric. As you can see, Roboelectric is really good because it can do the configuration of many different data within the Android system. Here, as you can see that config annotation, we can say what level of Android we are wanting to use, but unfortunately there is no such configuration for the manufacturer. This can only be done with reflection, which Szugyi already told a lot of that, why it's not the best thing to do. And the other part of the test is just checking. It will be a working test, but it is important to mention that here you can see this exact test in the first line and all the different permutations of these checked. It is over a second for one test and almost 2.5 seconds for the 6th test. I think that's a lot, especially if we have a huge system with a lot of tests. That's not really bearable after a point. So let's do some refactoring. I created a simple data class containing this manufacturer and SDK version information that we will use within our classes. It can be later easily created within our DI system and injected everywhere when it's necessary. And also so the refactoring actually happened to the permission repository. No more usage of the build class directly, but we are using this build info provider injected. How did our test change? Well, it became pretty simple. No more need for Roboelectric, no more need for reflection. You will just create your simple build info provider object. Or maybe you can even use mocks if, for example, that class has too many properties and you just want to use a few of them. Pass it to the repository, check, it will work. Let's see how the timing changed. Well, it changed a lot. From one test, it was over a second, it went down to 80 milliseconds, and for the 6th test, it went down to 21 milliseconds. That's a huge win. So, yes, you need to consider what type of test you need to write and how to use mocking, Roboelectric, or reflection. Hint, don't use reflection. As you can see, as a summary, avoid reflection. This is one of the most important things. And actually, to be able to avoid reflection, you need to write tests. It is really important to test, especially if you have a feature-rich application, you have a lot of domain logic within your application. It's really important, as when refactoring your code, creating new feature points within your application, you need to know whether you cannot ruin the previous application with your new improvements. And throughout our whole presentation, the most important rule we followed is to use the dependency injection pattern. To keep your classes minimal as possible, you will need to inject the dependencies so you can write more thorough tests and you will have a better application at all. Okay, thank you for your attention. This was our talk about testing with Szugyi. And if you have any questions related anything, we are here to answer.